July 20th, 1969. Humans walked on the moon for the first time. The Apollo 11 mission with Neil Armstrong, Buzz Aldrin and Michael Collins was a defining moment in history. It was more than a scientific mission. It was a symbol of human ingenuity and the drive to explore. Born from the Cold War and the space race, Apollo was about national pride as much as science. President Kennedy's bold goal: land a man on the moon and return him safely before the decade ended. This challenge pushed technology and people to their limits, leading to breakthroughs in computing and rocketry. The Saturn V rocket, still unmatched in power, launched the astronauts with technology far less advanced than today's smartphones. Apollo's focus was simple: get there, plant the flag, and come home. The astronauts spent just over 21 hours on the moon, collecting rocks and making history. But times have changed. Our ambitions are bigger, and we understand the risks more deeply. Now, we aim to return to the moon to stay, to learn, and to use it as a stepping stone to Mars. This new era is about building, not just visiting, and that makes the challenge far more complex. If we've done it before, why is going back to the moon harder now? Because Artemis isn't Apollo 2.0, it's a whole new mission. Artemis aims for a sustainable human presence, not just a quick visit. Apollo was a camping trip. Artemis is building a research outpost. The old Saturn V rockets are museum pieces and the expertise has faded. We're inventing new rockets, spacecraft, and life support from scratch. Artemis targets the lunar South Pole, a place no human has explored, where water ice could support life and fuel future missions. The South Pole's harsh terrain and extreme temperatures demand new technology. Rovers, power systems, and habitats that can survive the coldest places in the solar system. The reward? Learning to live off the land, making long-term settlement possible. It's harder, but the payoff is bigger. A foundation for humanity's future in space. We're not repeating history, we're building it. The risks are greater, but so are the possibilities. That's why harder is better. Apollo was a sprint. One rocket, one mission, one shot. The Saturn V launched everything at once: command module, service module, lunar lander. Astronauts landed, explored for a few hours, and returned home. Simple, direct, and disposable. Artemis is a marathon. It's modular, sustainable, and international. The Space Launch System sends Orion to lunar orbit, where it docks with the Gateway, a small space station built with global partners. From Gateway, astronauts board a separate lander to reach the moon's surface. This approach is complex, requiring multiple launches and precise coordination, but it's flexible and scalable. Gateway can be resupplied, upgraded, and used for many missions. Artemis crews will stay longer, do more science, and prepare for Mars. It's not just about getting there, it's about learning to stay. The Human Landing System, or HLS, is Artemis's key to the lunar surface. NASA chose SpaceX's Starship, a massive, reusable spacecraft, as the first crewed lander. Starship is revolutionary, huge, fully reusable, and designed for the moon, Mars, and beyond. But it's risky. The technology is still in development, with dramatic test flights and plenty of challenges. Starship must be refueled in Earth orbit, a complex maneuver never done before. This adds risk, but the potential reward is enormous: more cargo, more crew, and the ability to build a real lunar base. If Starship succeeds, it could make moon missions routine and affordable. NASA is betting on innovation, accepting short-term risk for long-term gain. Starship is a gamble, but one that could change space exploration forever. High risk, high reward. Money shapes every moon mission. In the 1960s, NASA's budget was massive, over 4% of federal spending, driven by the urgency of the space race. Today, NASA's budget is less than 0.5%. Artemis must do more with less. That's why Artemis is collaborative and commercial. International partners like ESA and JAXA share costs and provide key hardware, like Orion's service module. NASA contracts with companies like SpaceX, leveraging private investment and competition to drive innovation and cut costs. This public-private model is efficient but complex. Delays or setbacks in one area ripple through the whole program. Managing a global, multi-partner mission is a logistical and political challenge. But it spreads risk, fosters cooperation, and makes the program more resilient. Apollo was a national sprint. Artemis is a global relay. The economics demand it. Today's moon missions are defined by caution and safety. Apollo astronauts accepted high risks. The nation was driven by urgency. Tragedies like Apollo 1, Challenger, and Columbia changed everything. Now, safety is paramount. Every system, every procedure is tested and reviewed. The Orion spacecraft has multiple redundancies and a launch abort system, adding years to development but saving lives. Artemis missions are methodical. No shortcuts, no go fever. Spacesuits and landers must meet strict safety standards before carrying astronauts. Commercial partners like SpaceX must prove their vehicles are human-rated. This meticulous approach slows progress, but it's the right call. The goal: get there and back, safely, every time. Why go back to the moon? Because Artemis is about the future, not the past. A permanent lunar presence means new science, new technology, and a training ground for Mars. The moon's south pole holds water ice and secrets about our solar system's history. Long-term missions will let us build observatories, extract resources, and learn to live off-world. The moon is a test bed for Mars, close enough to rescue, far enough to challenge us. Artemis inspires a new generation and models global cooperation. Exploration drives innovation and unites humanity. The risks are higher, but so are the rewards. We're not just going back, we're moving forward. Artemis is the next giant leap. The journey to the moon is just the beginning.